show you some more, like Stata applications. That's right. I was running with models uh, because for some reason I was not able to um, get the data that are used for this application. Now, is it too small, right? Okay, let me. Can you see this? Can you read?
Yes, now it's good.
No, it's okay. So some of the things that I'd like to point out is just using the data. So what happens is that, well, you remember last time, Dr. Jaginder was showing you how to import data from Excel. So again, it's better to have the data in the form of a data file. So if you look at this line number 6 in here, okay, so it's a use join data S. That is, this is the data that you can create after the, getting getting the Excel file. Okay. So then again, like you don't have to go back and look at the data file if you don't want to. But again, if you want to see it, you can always get an idea. So here again, I mean, in this setup, all I'm doing is say use that data set. So this is again a data data. Okay, this is not an Excel file, but again, if you have an Excel file, you can also use that. And this is again like some I put that commented out. So when you put a star, that is commented out. So these are some of the variables that we're creating. Okay, that's on. This is a new data. Okay, so these are different variables that are used, and then again you can just see that, well, this is the generation command. Gian ly1 is log of y1. Gen ly2. So this is how the different variables are created. Okay, and then if you look at line in here 43, then I'm doing dx2 is lx2 minus lx1, and so on. So d variables are, remember, this is when we were talking about input distance function. I just said the one variable on the right hand side are expressed as ratios. So if you want to use x1 on the left hand side, a log of x1 on the left hand side, the right hand side x variables are going to be x2 over x1, x3 over x1, and so on. So this is how you create those variables, right? So again, that dx2 is basically log of x2, which is defined in here, minus log of x1. Okay. So then what is going to be happening? I'll be using an input distance function. Okay. And again, I created a variable for output distance function also, right? But again, it depends on what you want to use. Okay. And then there are some z variable, and again, z to acid ratio. So in line 49, yeah, I can see that, right? So again, this is a z variable. That means we are going to be exploring whether the financial situation of the firm, which is given by debt to asset ratio, is playing any role in efficiency. Okay, and then again, like time. Remember, we are putting time variable. Purpose of the time variable is to show whether there is a shift or technical change. If you recall, when I was talking about the TFP decomposition, then one part was technical change, and technical change is represented by a shift in the function. Now there are two ways of doing it. One is to put time dummies, and the other one is to use a continuous variable. I prefer to use continuous variable because again, like you can take a derivative, and that will show you, the magnitude of the shift. Okay. And then again, Dr. Jaginder was talking about it also in the last session that instead of adding all those variables, you can make a list. So again, you can use a global command. So global y variable, you can just have one or two. Again, in this case, again, It's not necessary. If you have only one, then there is no need to define a global Y variable. But global X list, again, you have LX1 all the way to LX5, and then again Z list, I have only one, but again, you can have more than that. So again, like this global command will create this list variable, and then again, you can change the name. Remember, X list, Z list, and again, if you think in terms of running several models, you can now with different X variables, then you can just say that X list 1, X list 2, and that type of thing. Okay. Now, this is in this a particular formulation. So again, this is SF model, the type of thing that is used in the book. Okay. So if you want to use this one, this is not SF cross. Okay, so I'd like to point that out. And I told you there are many different ways, even in SCADA, where you can use stochastic frontier. So SF model is the command that is used in the book. Okay, and if you want to use that, again, everything that is in the book can be downloaded freely. Okay, so again, let's look at the sequence of things in line 66. So you have SF mod, that's kind of the command. You are asking the computer to use that particular command. That means whatever is in SF mod is going to be, you're asking the computer to get to this. And then your Y variable. So if you have a list, then you have to put a dollar sign in front of it. If it is not a list, then again you can just have LY1. Okay? And then again, see that all this is orientation. Again, here it says production. So the orientation is output oriented. So we are not saying that all orientation O, but simply saying production. Okay. If it is a cost, then again you just replace production by cost, meaning that one is V minus U right now, but again V plus U, when you say cost model or input distance function, you have to put a plus sign. So that would be represented by changing this production to cost. And then this is distribution, H is abnormal, and again, this is the frontier function. So you are writing frontier, okay, and then X list. That is the frontier function, f of x, has these variables that are listed in here, and you go back and then see that what are the variables in the list. So you have log of x1 to log of x5. Those are the variables in the list. And then again, these two other things, Q sigma, that is your sigma square U, and V sigma, sigma square V. And now inside the parenthesis, there is nothing. Then these are random variables, there are no determinants of inefficiency. Okay. Now you can easily change those things. Like if you put in here Z or $Z list, then again it will be going over and then finding out that Z variable or Z variables, and they are going to be used as determinants of inefficiency. Now we have not mentioned this thing, sigma V can be also, you can put some variables in there. So that would be what we call heteroscedasticity. Okay, so these variables can be anything. So one thing that is, I would like to focus that this X list, if you want, you can put this X list variables in here also, in two places, because this is not a linear adjustment. But what we encourage people that you think in terms of variables that can explain inefficiency. And those variables should be variables other than x or other than inputs. So for example, in our case, we were thinking in terms of using this debt asset ratio. Okay. Now this thing, this is 67 and 68, you can ignore those things. But sometimes when it is difficult to get convergence, we start with giving some initial values. So in a nonlinear estimation, okay, you will be better off if you start with some given initial values because the parameters, okay, will start from somewhere. In OLS, you don't need to get an initial value because you have a closed form solution for OLS. But in a maximum likelihood, there is no closed form solution. So this is what you have to start from somewhere and then you get it, just like a hill climber. think in terms of climbing a hill, and you get to the top, so you go from somewhere, right? You don't go to the top right away. So you start from somewhere and then gradually climb all the way to the top. Okay. So it would be better if the starting point is not somewhere very far. Okay. I mean, most of the time it doesn't matter, but I'm just saying that well, you can be or the number of iterations can be fewer if you start with some initial value that are like not way too far, or you think in terms of not a smooth thing. So you're looking at a hill, and again it's not like this, not smooth in a cassette. Okay, there are some dips, and you might fall into the dips, right? And the algorithm tries to go and pass this dip, but again it's stuck in there. Right? So if it happens, then again it will go in again and try to increase the step size, but sometimes again it's unable to get out of that path. Okay. Um, and then the 68 is also something like search. It's asking you to do that to search. But again, the 67, 68, you can just definitely ignore. And then again in 69, he is saying that what you do maximum likelihood. Okay. Can you guys in the back stop talking and either you go out and talk or just if you stay inside then you need to stop talking. So 69 is saying that ML is maximum likelihood. Okay, you're maximizing that. And again, these are some other comments that are related to convergence. So how do you know that you are on the top? Okay. So what happens that well, if you take a small step to the left or right, there will be no change, right, in the value of the objective function, meaning that value of the likelihood function. So again, you can set these things very small to indicate that well, you are literally at the maximum, right? You are not again like far from it. But again, you can ignore those things completely. I mean, sometimes people change these things, make them smaller to get a quick convergence. Okay. Okay, so this is the key thing. This 66. This is as a model, and then again like so this is maximizing the likelihood function to get your parameter estimates, and then again like we are calculating efficiency or inefficiency. So again like I put star meaning that well it is not a command. It's just kind of a I mean it's a command line for you to read that one what you did in that. Okay. So then again, like this is prediction. So again, the predict command is different depending on what you use. Like in SF cross, it was simply predict. But again, like in this code that is associated with the book, it's SF predict. Okay. So if you use predict, you will come up with an error because predict command goes with a different different package that is SF class. Okay. Um, so again, if you follow these things, again everything will be fine. No, there will be no error. Okay. And then again, we have both LGL MS. So this is John Drew, Label, Maderov, and Speed. So that this is estimating inefficiency, expected value of EU given epsilon. So remember, I just showed you that this is the formula that is used to estimate inefficiency. And then again, so this is the name that is used. Again, a long name, but again, you can just make it put any name you want. So JLMS tells the computer that you are looking for estimates of inefficiency, and then inside the parenthesis is the name. Okay, and then again, after space is a DC. So this is kind of associated with the estimate of efficiency, e to the power minus u. And then again, inside the parenthesis is the name for that. Okay. So then again, after that, you can just do a histogram or summary statistics, whatever you want to do. And again, this is going to be in the memory, so again, you don't have to do right away. You can do some other things, and then you go back and say, oh, I forgot to get the summary statistics. So you can just have some and then name of the other variables. So it can be done at any point in time. Okay. And then again, going further, so now this is the SA model. See that we have the command line, that SM model with truncated normal distribution. And mu is parameterized by Z. So you have mu, remember what Dr. Joyendra was talking about, that means you had E mean, right? So the mean, but we are just saying, well, the mean is not a constant. It's a function of some other variable. So the model can be very complex. You can have the mean function of that variable, you can have the variance function of that variable. Okay? So this illustration says that what, so as a model distribution and see that what this is T. T for truncated normal. Okay. Frontier is the same X variable that goes in the frontier, and mu, that's kind of the mean. So instead of E mean, the command here is mu. Okay. And again, inside the parenthesis, say that what this is the Z variable. You can have one, we have one in this example, but you can have a list, meaning that well, you can have many Z variables in there. And then U sigma can be sigma. Okay. So again, there is nothing in there, but again, you can put your Z list in here as well as in here, or some other variables if you want to. And then again, in here it says production. So the model is production. Okay. Not a cost. So you have to tell, again, if you forget to do that and you run it, it will say that well, it will come up with an error message saying that you forgot to mention whether it's going to be a cost model or production model. Okay. I think one is default, that being production. So if you write production, it will work because it by default is the production model. Okay. Okay, so see that well, I mean SF initial value, I just commented it out. Okay, and again you can comment out this one, and then again ML max, and then again you have the same command before. But again, if you don't want this extra things, the program will still run, and it will give you the estimates. Okay. So now again, you can do the same thing, calculate inefficiency or efficiency. So now accept predict, the same command as before, and then again the GLMS. So this is EFF and see that T, so that I can distinguish the names. So there's two names. This is H to indicate that well, this is inefficiency estimates coming from abnormal. Okay. Now here we're just saying that okay, this is a T coming from the truncated normal distribution. Okay. Because if you put the same name, well, it will work, but then again, you cannot call the previous one back, right? Because that is going to be replaced by the new one. Right? So it's better to change the name so that you can call it at any point in time. Okay, what is next? And then again, BC, this is efficiency estimate. Again, you can see that I will put T in there to separate it from this one, which has H. Right? So this is abnormal, this is truncated normal. So just a different name. You can just say that efficiency 1, efficiency 2, and that type of thing. So it's up to you, the way you feel comfortable. Okay, just to show all those things, because again, Dr. Joyendra has shown you only half normal, he was doing only truncated normal, but then again, I asked him to change that to half normal, that was also working. But again, now I'm just showing that I started with half normal, then I went over to truncated normal. Now let's just look at this exponential. So the SM model with exponential distribution. So again, you do the same command in here. This is the difference. So dist and then this is E. So this is saying that well, the distribution for inefficiency is exponential. Okay. And then again, this is a little bit annoying because we keep on changing this thing. So frontier part is exactly the same, but for some reason, U sigma and V sigma is exactly the same. But instead of E sigmas, it's written as etas, ETAS. Okay. So again, you have to know exactly the same. The sequence of commands. If you use sigmas in here, it won't work because for some reason, for exponential, the name is changed from U sigma to etas. Okay. But again, this part is associated with the one-sided error term, and this is the two-sided error term. And then again, see that all now, I suppress both the comments, that is the initial value and search. Okay. I mean, if you do sort, then you will see the graphs coming after one after another, and sometimes I find it's annoying. I want to let it run. I don't want to see what the computer is doing inside. Okay. So I go to 92, and then in there you just simply say that well, you just maximize the electron function and get the parameter estimates. Okay. So then again, you calculate efficiency or inefficiency. Now here the comments are exactly the same. So if you look at line 96, GLMS is the estimate of yield, and then again inside the parenthesis is the name that you are giving. So you can, that's I mean, I think it should not be efficiency. You might just say inefficiency, but it's up to you. And then the second one is, like you get this query, so that's efficiency. So we're done with three different things. And then again, you can say the well sum. If you look at 98, and again, you have the estimates of efficiency coming from three different distributions. Right? So you can just see whether the distribution assumption is making things different. Right? Sometimes you want to see that, I mean, because people will say that well, whether your estimates of efficiency or inefficiency are driven by distribution assumption. Okay, so in order to answer that question, you might be better off by just saying that, well, look, I run all the models with three different distributions, and these are my results. Okay. Okay, any question up to now? So again, this is basically continuing with what Dr. Javinder was talking about, but now I'm giving you the full list, meaning that all the distributions. Okay, and the basic thing is maximizing the likelihood function, and then predicting the estimates of inefficiency. And then again, instead of sum, you can do a histogram for each of those, just to get a better picture. Because if you do sum, some other statistics is just giving you the mean, and then again like the maximum, minimum, and that type of thing. But sometimes you want to see a little bit more, not just the mean, because if you think in terms of two variables, they might have the same mean, but their distributions might be very different. So when you look at the histogram, that gives you a better picture. Okay. So now let's just think in terms of using distance function. We talk about distance function, and that is the case when you have more output. Okay. So again, you have two outputs in this example, and then again, like if the dependent variable is log of y1, and remember, if you have two outputs and you are using output distance function, then you have to use the other output normalized by the first one as an additional data set. So if you look at this one, okay, so you have the X list. Here I changed that X list. You have LX1 all the way to LX5. You have 5 different inputs, and see that dy2. So what is dy2? It's log of y2 minus log of y1. So you can go back and look at the definition of this. So this is kind of like y tilde, the way the notation that I introduced. So if you have more than one output, the right hand side should include the output variables normalized by the first output. Okay. So that has to be defined, and again, like it has to be included in your X list. So again, in addition to the X variable, you are adding this dy2. You can do dy3 if you have 3 outputs. Right? So the number of outputs does matter from the computation point of view. And then again, you just go to abnormal distribution. So again, what do you think will change? Do you expect to see any change in terms of the code? No, because you put dy2 in the X list, right? So you basically copy all the lines that we had before. But remember, this time when you look at the output, there would be again a variable dy2, and there would be a coefficient for that. So that is the only difference. You are adding one extra variable in your regression, meaning that what in your frontier function. And then again, for doing efficiency or inefficiency estimate, it's exactly the same. So as I predict, DLMS and efficiency DH, D for distance function, H for abnormal, and then again like efficiency, DH, DC. So this is kind of, first one is GLMS is for inefficiency and DC is for efficiency. Okay. So again, like this is how you do things. And then again, I put this I'm sometimes lazy, so if you put something that the computer doesn't recognize, it'll stop it there. And I just put a just saying that well, computer doesn't know what it is. I'm asking the computer not to read the rest of it, so it'll stop it there. Okay. Um, but then again, if you continue looking at these things, again, you can just see that, again, this is the example of truncated normal. So what you are saying that, oh, okay, the one other thing you want to do, so let me go back in here. So this SN1 in here, so this is a Hausner distribution. This is called output distance function. If you want to do input distance function, then what? Then your X list would be completely different, right? So X list would be what you want to keep X1 on the left hand side, okay? And then again, other X lists have to be normalized by X1, right? So remember in the very beginning, I defined dx2, dx1, dx3. So these are going to be log of x2 minus log of x1, log of x3 minus log of x1, okay? So you put x1 on the left hand side, and the right hand side x's are going to be again in the ratio of each and every x normalized by the first one, right? And y's are going to be unaffected. So this the list that you had for distance function in here. So this list is for output distance function. So if you do input distance function, then this is going to be dx1, dx1 is basically here. So dx2, dx3, dx4, dx5, and then again instead of dy2, you will have y1 and y2, two different outputs. Right? So and then the rest of it is exactly that. So the only difference is that okay, you have to say about this production, so you have to change that to cost. Okay, because now this is input distance function, and why you need to change it to cost or why there will be a plus sign? Because if there is inefficiency, your input use is going to be more than what is needed. Right? What is the minimum? So that's kind of the intuition that you need to put a plus because in a input distance function, your input is on the left hand side, so the inputs are going to be used more than the minimum amount that you need to produce the given level of output. Okay. So then again, you can see that well, it's not only production function and cost function, but input distance function, output distance functions are basically again can be estimated exactly the same way. With z variable, without z variable, only thing that you do is this you sigmas in here. Okay, you put the z variable that you want to input in your model. Okay, and then again like these sigmas I didn't mention it again. I just told you that you can put also some variables to indicate that the variance of the noise star is not IID. It is electroscholastic, and the variable that you put in there will be expanding electroscholasticity. Okay, so that kind of gives you the entire picture. And then again in the morning, the first session, what I was talking about, this is non-standard application that will fit in there too, right? All you do is that remember in your head is you were talking about output. This is not output anymore. This is investment. And then again, like the right hand side variables are the variables that can explain your investment behavior. So no matter what you do can be fitted into this type of thing. So the first setup is very, very simple. If you want to follow the model that we discussed, then again you don't have to do a whole lot. Okay, you can use the standard codes to estimate all those things. Okay. So then again, like I just said, that when it comes to showing you how to do things, I mean, one session is sometimes more than enough to do it. Again, I am not running this thing because if I try to run it, I think the data that is in here that is too old, for some reason SCADA is not reading it, and I cannot find out what is the problem. So this data is there in my computer, right? But for some reason, it comes up with a message that it is not a SCADA data set. I don't know whether it's because of the fact that this is 10 years old. That is this data I created 10 years ago. And again, the way the SCADA is formatting the data recently might have changed. That's why it's not reading. So my SCADA is 16 versus the latest, right? 16, whereas this data set that I created, it was after 2011. So I think that might be the reason. I mean, I can try and see what happens. But this is what happened in the morning for more than 1 hour last night. I was saying that the internet there is so slow, and even though it doesn't require any internet connection, because just using the data inside the computer, and then the software is in the computer. But I mean, there is nothing, no response. Okay, it's supposed to run it, and I don't see an indication of it running. Is it? Yeah, see that file and this data set is not SCADA format. So my guess is that again this is kind of the old format. This is SCADA data set, there's no doubt. And I mean that's why I was saying that well, if you have any data set that you are using for your research or you have access to it, we could have used it. But anyway, you know this thing because Dr. Jaginder was showing you in terms of some data, but he was not running it. I could run it in my computer, but unfortunately, I don't have the particular data set that I am, the codes are ready. So if I change that, that means I have to change everything. It should take time. Okay, so any further questions? You should have some questions, right? I mean, I mean, you might be afraid to ask, but again, I'm just telling you that, well, you don't have to be afraid. And this is the culture. I mean, I know that, I have gone through the same thing. I did my master's, from Kolkata, but I don't think at that stage I asked any question. So this is sometimes, and again in the college, somebody outside came and did a seminar, and the principal was saying, okay, why didn't you ask any question? Nobody was asking any question. I don't think that we didn't have any questions, but for some reason, it's when you listen or when you say the professor is saying, so he or she must be right on everything. Right? But the first thing that I just say in the US that yes, I'm a professor, but I don't think that whatever I'm saying is always right. If you have doubt, you should express it. And then again, the things have changed so much. At least for me, maybe this is kind of cumulative effect. Because many years I didn't ask any questions. So if I'm in a seminar, I sit down for 10 minutes and I cannot stop asking questions. Right? So it's impossible for me to listen without asking questions. Sometimes I ask too many questions in a conference. There's always a limit. I mean, you cannot monopolize and ask too many questions. But if something is kind of itchy on my side, I feel like asking questions or sometimes too many questions. So yeah, feel free. No question at all?
No, sir.
Oh, okay. So you're just arguing like when our principal says there are no questions, because the professor explained it so well that we don't have any questions. Sometimes it might be true, the subject matter you don't know, and they get your explanation or the professor explained in a way you say that, well, yeah, that's perfectly clear to me, and I don't have that. So the way we start in the US is, in order to do research, you have to start with a question. Maybe that the person got a Nobel Prize, but that doesn't mean that everything he or she is saying that we're not talking about right or wrong, but you might say that yeah, I mean I can look at it differently. I think instead of asking. Okay, so it looks like time is up, and for listening to me for the last full 4 days, right? I hope that you learn something and that might be useful sometimes in the future. Otherwise, this is kind of wasting your time and my time also, right? Okay.
Thank you so much, sir, for your dedicated and insightful lecture. I hope all the participants have learned so much from you. Now your test will be conducted, okay? And we will distribute the sheet to you. There will be two sheets, and it is an objective type question paper test, okay? Only 10 questions are there, and very easy questions also. You can answer it if you heard these lectures very carefully. Okay. So I hope you will mark up to 100. Okay. Okay, Manisha will distribute. Okay. Session, and Rampul sir will take that session. Okay. And after that there will be a lunch, and then 2 to 3 valedictory sessions. In that you will get your certificates also.